The next speaker, he's from Peltarion, and he's the CEO, and AI is Peltarion's core business, and I'd like to give a warm welcome to Luka Crnkovic-Friis. You're with us here in real life.
Thank you. Oh, I just have to take a photo of this, of a conference in Corona time. That's too good. All right, so my name is Luka Crnkovic-Friis. I'm the CEO of Peltarion. And basically what we are doing is we're trying to radically lower the price of deploying AI. And with AI, I don't mean the lot of older technologies that are being rebranded as AI. I'm talking about the really cutting edge stuff, deep learning, that has been really propelling the AI boost that we've seen in the past few years. And what we've seen historically with our other technologies is when you seriously reduce the cost, it's when magic happens. And basically, we want to make sure that AI can be used everywhere and really supercharge everything. Our way of accomplishing this is we're building an enabler, which is a cloud-based platform that allows non-data scientists to build cutting-edge systems and put them into production. So basically making the technology far more accessible, but without taking, sort of simplifying it too much in terms of its power. We're not technically a startup. Founded in 2004. It was me and my co-founder Måns. And we had a product called Synapse, which was a development environment for neural nets. And we had some 300 companies using it, 10,000 users or so. And then by 2016, it was still just the two of us. And the market was really taking off, and we decided, okay, now's the time to scale this. And we got EQT and then the Wallenbergs on board, and later Euclidean Capital. And they came on board because there is right now a big opportunity in the market where the global tech giants and China are completely dominant within AI when it comes to algorithms. So coming up with new stuff there. Europe is vastly behind, Sweden is vastly behind. But we really do have a chance of building a global tech giant out of Europe, taking lead in technology. And if you look back historically, take the Industrial Revolution, it wasn't really the steam engine itself that sort of propelled it, that scaled steam technology. It was when the machine tooling for building steam engines became available and very cheap. So generally, most companies are in one way or another in trying to get some AI, get digitalized, get ready for the AI first world. And most are doing it in a wrong way. That tends to be super expensive, and that's because they tend to confuse AI and analytics. Two vastly different things. So if you look at analytics and big data, it's all about centralizing all the information in the company, piping it through a data science department, does the interpretation, and out comes some sort of actionable intelligence, information, how your business does, forecast, and so on. And this is super important, but it's also very, very difficult and a very long process. So centralizing all of your data, I've seen no company that's had an easy way of that, especially the more traditional ones. So AI, on the other hand, AI does not provide insights. It provides a concrete solution, either by optimizing something so you can cut costs, or that you can create new services. And it works best when it's distributed. AI works when it's put into the hands of the domain experts, rather than into the hands of generic domain data scientists. You can imagine, say, an antenna developer at Ericsson who's been working there for 30 years developing antennas, that there's some newly graduated 20-year-old data scientist comes from a central department and say, oh, you're building antennas. Can I be of some assistance? Would you like some AI? It simply doesn't work. The sort of domain knowledge is the difficult bit. The AI isn't really. But there are two major obstacles today towards this really getting into the hands of the domain experts. And one is that it's very hard to find people. And the second one is that it's the technology is based for research. Now, if you look at the sort of data science part, the road that most companies are taking is that the cost of finding a mediocre data scientist is hard. Finding a good AI expert, that's nearly impossible. That's almost reserved for the big tech giants. And if you look at the sort of gap between availability and demand, this is a report from IBM and Kaggle that showed that there were what they qualified as 35,000 data scientists with sort of modern skills in the US, while there was a need for about 700,000. So this skill gap equation doesn't work. The second thing is, when most people have the conception of AI, how you build an AI system, is that you get some data, you build a model, train it, then you analyze the result, possibly repeat a bit, and that's it. But that's not reality. Reality is sort of this piece of building the model and training it. It's really, really a tiny bit of it all. So the whole process involves everything from configuring different toolkits to data management, version controlling experiments, serving infrastructure, monitoring, and so on. So there's a lot around it. And the way that most try to solve it today is by using a ton of different tools for each of these sort of steps. And those that succeed, and there are few, relatively few that do, they end up with something that's not scalable, it's not maintainable, and it really requires very high-level expertise, both on the software engineering side, DevOps side, and data scientist side. Now, so what's the alternative? And this is where we're coming. Now, the world today, AI world, the tooling provided by the tech giants and that exist in the market are typically divided into sort of two very broad categories. One is the super powerful tools like TensorFlow, PyTorch, or we have Amazon SageMaker, where you can do a lot. You can solve almost any modern AI problem with it, but it requires expertise and it's built for research rather than production. And then at the other end of the spectrum, and I'm going to skip them, discussing them more in detail because they're really not relevant, are the sort of auto AI or auto MLs, super simplified, where in theory you press one button and out pops an AI model. The problem is that it doesn't work that way. Building an AI model still requires a bunch of iteration. You have to have your own data. You have to have support for many types of data and so on. So those are most for toy problems. So you have the choice today of either going by something that requires expertise that you can get or something that really doesn't work. But comparing the sort of more powerful system, so I'm going to show you a video of a person using Amazon SageMaker, a PhD in machine learning, certified on AWS. And on the right side is of our platform. It's one of our tech writers who did that. Familiar with the platform, but an engineer by education, so not a data scientist. And the challenge, the problem, relatively simple. So you have some images of car damage and some tabular data that says which manufacturing year and things like that. And they were to build a model that classifies the damage based on the image and on that metadata. Now, you don't have to understand really what goes on in the screen, but it's more of a, like the difference of what you see. Let's see if we can get the video going. Oops. No. Well, that's a pity. Okay, I'll just narrate what happens in the video, although it's slightly less effectful. So basically, when we had a combination of images and tabular data, a person using AWS wrote tons of code for an hour and didn't get the first version to work. On our platform, it was done in like 4 minutes, and then sort of a follow-up was just to use image data because they had trouble on the Amazon side. And it took like 2 minutes on our platform. It took an hour on the other. And what you ended up there is, still doesn't work. What you ended up in one case is a lot of spaghetti code that really can't be put into production. And losing a bit the point when you didn't see the video, but there is like a vast difference. There's an order of magnitude of speed, and in one case you can actually just put it into production. In the other case, you would have to have a big team of DevOps and so on to get it into shape for production. And this is actually, and we have a very good relationship with both Google and Microsoft, and we have deep collaborations with them. So we've both technological and otherwise, and we've got it validated now over and look at that. It works. So now it's fast forwarded. You can see the platform here, the graphical platform. Well, this is the code. It's very low res. It's actually done on the right side. This was just calling the model. So, and then we had the second case, which was, we simplified it for the AWS sake, and they were allowed to reuse all of their code. And this was done like in 2 minutes or something, 3 minutes. While, yeah, they got it to work, but it took about an hour. And when you would have to do it again, it would take an hour again. So it's not just a one thing. Can we get back to the presentation? Thanks. But this is a sort of what we have validated so far is that although we are seriously behind in Europe and Sweden when it comes to algorithms, sort of all of the really awesome things happening in AI are coming from the US, with China as a second, and Europe far behind. But where we are world class, where we do actually have a chance of establishing a meaningful leadership, it is in tooling around AI. And hopefully eventually we'll also catch up on the other side. So this was a bit of theory. A couple of, let's see how, we're doing good. A couple of examples of practical customer cases, so you get an idea of how this is can be used. Ericsson, so they answer a lot of RFPs, like 5,000 per year, and they have 500 people sitting in India doing that semi-manually. And they have a department in Sweden that double checks those results. They were able to automate most of that now with AI, and it meant 10 million per year saving, 15x ROI the first year. completely different end of the spectrum, Sybase, small Swedish company, creates a probe that was originally used for melanoma detection. And they had this idea like, okay, if we add images to that and use AI, can we get better results? And they were a really early platform customer, and then they got some results, but they weren't great. They were a bit better what they had, but nothing that really justified of going in and sort of getting new FDA approval and things like that. And then about a year from when they started using our platform, we had a meeting and we were pretty sure like this is a churn, but they seemed pretty happy. And they said, yeah, the melanoma thing, we stopped working on that, but we found a different use case. So there is a membrane in the skin that protects the body from things getting in, things that shouldn't be there. And basically, the quality of that varies for some reason over time. And when it's weak, then people with allergies get eczema and things like that, rashes. And the only way to measure that has been to do a biopsy, and you had to do it on skin where there was a rash. But using their probe in our platform, they built a model where they could, on clear skin, detect way ahead when that membrane quality was going down. And basically, this became a very important part of their business. So they're focusing a lot on that now. Why I love this example is because we at Peltarion who know AI know absolutely nothing about skin. We didn't know there was a membrane. While at the same time, so we couldn't have come up with this use case. While at the same time, they couldn't have done it without our platform because they're medical engineers. They're not data scientists. And then as that meeting was ending, they said, oh yeah, we have a second thing in production. Over the summer, we looked at our quality control. So they basically have each of these probes, the tip is controlled by somebody looking in a microscope and seeing that there are no defects. And over the summer, an intern, who was the CFO's daughter, built a model. They bought a video microscope, and she built a model to predict these quality variations. And they were able to automate that step fully. So Sybase, fantastic company. Elekta, brain tumor segmentation, as good as the best doctors in the world, and there's a massive shortage. Typically, today, the treatment when you have a brain tumor, the first thing you want to do is radiation therapy. But the queues are super long, so between diagnosis and the radiation therapy, the tumor moves very often, and they end up irradiating the wrong place in the brain, which is bad. So being able to speed this process up and automate it, Elekta, they want to put this in actual machines so they can do radiotherapy at the same time, see sort of a real-time view of the tumor. Pretty cool tech. Epidemic sound. So they built a model that classifies music by mood. It was a part of their recommender system. Again, a great example of, at that time, they didn't have any data scientists, so there was just a bunch of their developers that were able to build this using our platform. Billerud-Korsnäs, optimizing paper quality, so it's classifying what type of, how you should process different pulp depending on the quality of the pulp. Husqvarna, floor grinders. So basically, with these industrial floor grinders, there are very few experts actually. In Sweden, there's only a couple who know how to operate these, because they hear on the sound whether they should apply more pressure or less pressure, or if something is wrong and so on. So we helped Husqvarna out there. So they put up microphones on those, collected data, and then built a model that could actually predict it as good as experts, meaning that you could get novice users to operate one of these big machines almost as well as the experts. Ipsos, Ipsos, that it's a marketing research company. So basically, traditionally, what they've done is when they have a product to review, they've brought people into the office and interviewed them while having a psychologist looking at them and writing down sort of the emotions. We helped them automate this with a neural net that recognizes emotions, so this can be done remotely. It meant a lot to them now during the Corona thing. Pandemic in the spring. Another example of Ipsos is slightly related to the Ericsson case I mentioned earlier. So one of the really cool things in AI that has happened in the past 2 years is text understanding. Basically, AI that can understand text on a semantic level. So you can have two sentences that don't have a word in common, but mean the same thing, and the AI will understand that. And, to kick it off, it works with any language. So apparently there's a semantic level that's universal for any language. So what we did there was they get a lot of surveys where they have free text. And before they had translators and a lot of manual processing, and we were able to automate that. So going from free text in basically any language to quantified numbers and things like that. So that was all I had. I just want to give you a feeling of what's happening in this area and what we are working on. Right.
Thank you. Please stay. I have one question for you from the viewers. Is Sweden doing enough to advance AI research and development at universities and institutes? Are programs such as WASP being enough?
No. I mean, it's great that we have those, but those are all coming from the private sector. I think there should be more of an effort to invest in that.
Let's take one more. About scalability. How scalable is the Peltarion platform?
Well, that's its primary point, that it is super scalable. You can go from a couple of people using a model to millions.
So that's really not a problem from your perspective. All right. Well, thank you very much for coming and sharing your presentation with us. Thank you.
Thank you.